Hello, everyone. I'm going to talk about cooking fuel choice, indoor air pollution, and child mortality. This is evidence from India, and this is joint work with Tsenguunjav, Byambasuren, and Nancy Chau at Cornell University, and Neha Khanna at Binghamton University. So the reason why we're interested in this topic is because household air pollution globally is a major contributor to mortality, and particularly so in East Asia. You can see in China and South Asia, which is Pakistan, Bangladesh, and India, as well as Indonesia. And part of the reason why household air pollution is significantly higher in these countries is because of the choice of cooking fuel by households, especially dirty fuels such as wood, animal dung, and crop waste. And in fact, the numbers are pretty significant. Worldwide, there are almost 4 million deaths attributable to household air pollution. And in India, 40% of all deaths are due to air pollution itself. There's a rich literature, there's an epidemiological or medical literature out there that has found a strong and adverse health impact of indoor air pollution. The issue, of course, with these studies is that there aren't enough adequate controls for health outcomes, and there isn't a convincing identification strategy. When it comes to the economics literature, we have quite a few papers, starting with Esther Duflo's work in Orissa, which is randomized controlled trials looking at adoption of improved cook stoves and the health outcomes related to smoke exposure. Rema Hanna in 2016 AEJ Economic Policy, of course, also works in Orissa and the uptake of improved cook stoves. And there are a couple of other papers that have looked at this uptake of improved cook stoves on not just health, but like Imelda on infant mortality in Indonesia. And Imelda does find a positive impact. In other words, households that adopt LPG stoves actually have lower infant mortality compared to households that continue to use traditional cook stoves. Our analysis is the first to take into endogeneity among studies where indoor air quality is proxied by cooking fuels. So what we do is we proxy indoor air quality by the type of fuel the household uses for cooking. And we point out that child mortality and the cooking fuel choice could be endogenous. And we use an IV approach to actually address this endogeneity. We utilize nationally representative demographic survey data, or the NFHS, which covers households from 36 states and 640 districts in India. As a background, the link between indoor air quality and infant mortality, at least when we eyeball the data and the literature, we find that 72% of households use solid fuels as a primary source of energy and for cooking. And the 24-hour average PM10 concentration in those solid fuel firing households is 15 to 16 times higher than that, which is the US EPA standards for PM10. There's also a robust literature out there that points to the fact that 20% of deaths amongst under 5 children is attributed to the use of solid fuels. If we look at the trends in the 4 types of mortality that we are concerned with, the first being the neonatal mortality, which is death occurring within the first 28 days of birth, post-neonatal being after 28 days but before a year, child mortality is after a year but before 5 years of age, and under 5 is just the cumulative sum of the other 3, the neonatal, post-neonatal, and the child mortality. What you do see is that at least in panel B and C, when it comes to post-neonatal and child mortality, the trends seem to be very similar for households that use clean and polluting fuels. However, when you look at the neonatal mortality, there is a significant gap. Even though the trend, you have a declining trend over the years, there remains a significant gap between households that use clean fuel and those that use polluting fuel. And this gap in neonatal mortality is picked up in the under 5 mortality, where we also continue to see a gap between households that use clean versus polluting fuel. The empirical strategy we utilize is 2SLS. We account for the endogeneity and use an IV estimation. The main outcome variable for us is Y, which is whether or not mortality happened over the respective age periods, whether it's neonatal, postneonatal, under 5, or child. And this is an indicator variable that takes on a value 1 if mortality happened for a child I in household age in village V in district S and survey year T. D is the variable interest to us. This is an indicator for solid fuel use. So D equals 1 is the household uses polluting fuel, wood, animal dung, or crop waste. X is a vector of household characteristics, place of residence, assets, where food is cooked, type of house. M is the mother's characteristics, including age and education. W is the child-specific characteristics, including gender and breastfeeding status. We use state-fixed effects, and we use time-fixed effects. And we also use state cross time fixed effects to account for any unobserved variability across space and time. The endogeneity that we're concerned with essentially are as follows. That indoor air pollution, for instance, causes respiratory illness and poor health that leads to lower earnings, and that traps a household into using cheaper and polluting fuels, which in turn leads to higher child mortality. On the other hand, you could start with high child mortality, and utility maximizing households value their health, so they switch and opt for cleaner cooking fuel. So both of these endogenities could be at play when you're trying to address this relationship. So the first state specification that we use, the choice of the cooking fuel, dirty or clean, which is captured by D, is now regressed on the instrument of choice over here, which is, for us, forest cover, the area of forest, and agricultural land ownership. So we talked about the fact that our data comes from the 3 rounds of the NFHS, 92, 93, 98, 99, and 2015-16. The outcome variable is infant mortality for the 4 different age groups. We talked about the key explanatory variables, which is the type of cooking fuel and the other controls that we have, and the two instruments that we're going to use. The key issue, of course, is the validity of the IVs, and the Hansen's J statistics suggest that the 2 excluded IVs are exogenous. You can see the correlation between agricultural land and ownership of agricultural land and under 5 mortality, as well as forest cover and under 5 mortality. And one of the reasons why we do pick these 2 as instruments is 50% of the households actually use wood. And being close to forested areas gives you easier access to wood, and ownership of agricultural land also gives you access to crop waste as well as animal dung. I mean, so both of these instruments are guided by what we observe in the data as to the kind of fuel being used by households. We also find that the 4 states in which we have the highest forest cover, for instance, Madhya Pradesh, Chhattisgarh, Orissa, Maharashtra, and Arunachal Pradesh, also seems to have high infant mortality. So this is one of the other reasons why we look at forest cover as an IV. And sure enough, if we look at the indoor air pollution and forest cover, right, which is the indoor air pollution being proxied by the choice of cooking fuel, both at the state and the district level, you find positive correlation. The same thing happens between indoor air pollution and agricultural land ownership. You see a positive correlation both at the state and the district level. So here are the results. We do find both our instruments to be significant in the first stage, and then we do observe that neonatal and under 5 mortality is positively related, significantly and positively related to the polluting fuel for cooking. We find the same thing for the probit results, both neonatal and under 5 mortality being heavily dependent on the choice of cooking fuel. We also run an additional robustness check by identifying states that have joined the Cook Stoves program, which was rolled out by the government of India. And we also find that accounting for this dummy, we still find neonatal and under 5 mortality to be significantly correlated to uh, polluting fuel choice. So in conclusion, our results show that there's a positive relationship between dirty fuels for cooking and infant mortality. We do point out something interesting, that non-IV estimates actually overestimate the association between polluting fuel use and infant mortality by 8 percentage points. So if you have a non-IV, if you don't use the controls and don't account for endogeneity, then the numbers turn out to be almost 203 deaths per year nationally due to polluting fuel use. On the other hand, when we control for the endogeneity and check for the omitted variable bias and so on and so forth, we do find 0.3 to 0.6 percentage point decrease, or in other words, only 76 to 152,000 deaths per year nationally. So not using the controls and not accounting for endogeneity actually gives you leads you to overestimate infant mortality. We are also the first empirical, offer the first empirical estimate of the causal effect of cooking fuel choice on infant mortality. We're addressing this endogeneity. We use tree coverage or forest cover and agricultural land ownership as the instruments. And we find at the end that the use of dirty fuels for cooking would increase under 5 mortality by increasing the neonatal mortality rate. Thank you.